Thank you, thank you. It is always slightly a nervous moment when you walk up to the stage and you don't quite know how you've been introduced, but I'm sure good things were said. So good morning. Thank you very much to the organisers for the invitation here this morning. It's a real pleasure to be here. I'm Stephen Bishop. I head up the Strategic Analytics and AI team at CMR Surgical. And I'm here today really to tell you a little bit about our approach to data and analytics in CMR and whet your appetite. Before I kick off, just a brief introduction into who we are. CMR Surgical is a company in Cambridge, UK. We were founded 5 years ago, and we have produced the Versius surgical robotic system, pictured on the slide. It's a versatile, collaborative robotic system with up to 4 instrument arms and an endoscope arm, 5.8 millimeter wristed instruments, an open ergonomic console design using a high-definition vision system that supports both 2-dimensional and 3-dimensional video. This year has been a really exciting year for CMR because actually all of the work that's gone into this has started to come to fruition. Back in March, we were awarded a CE mark for urological, gynecological, and general surgical laparoscopic procedures. And just in the last few weeks, we also made an announcement that we have hit some landmarks in our first-in-human clinical study. It's a prospective single-center study, primarily to look at safety of the system. And so far, we have completed over 70 cases. And we've also announced that the first 30 cases we have 30-day follow-up information on with no adverse events, which is a great place for us to be at this point in time. And we look forward to our progress in the rest of this year. But getting on to the meat of my talk now, what gets me, and hence everybody else, out of bed at CMR in the morning? And I love what our marketing team's done here with the subliminal messaging. They've assumed my answer, of course, is Versius, which is true. But it's not just Versius, the surgical robotic system. It's the platform, and it's the ecosystem, and it's how we all use it and integrate it into our working practices and our institutions and our patients' journeys. And it's that part that really excites me, both because I'm a computer scientist and a clinician, qualifying in anesthesia and intensive care before joining CMR. So I can't give a talk on machine learning and AI without a little example. So I had to sneak one in from Versius. What's actually impressive for me to have seen over the last 5 to 10 years is really how much progress we've made in the fields of data science and machine learning, to the point now where this type of technology, particularly in computer vision, is a semi-solved problem. Most of us carry it around in our pocket in some form. And actually, we're seeing great examples of it elsewhere in healthcare, in those specialties that are very image-intensive: radiology, histopathology, dermatology. There's some really good work going on out there. But does this solve all of our problems? And the answer is partly so. If you think back to where a lot of this technology has come from, it's come out of academia and a small number of industrial research labs. But the joy is, this type of technology is becoming quite commonplace. It's consumerized. It's democratized. You can go to any of the major cloud platform providers and start to do this for yourself, or do something like this for yourself. So this is actually an example from one of the systems we use. We'll be quite open about this. This is a service that Amazon deliver on their web services called SageMaker Ground Truth. And it's a very neat tool that allows any of you to do this. What do you need? You need a video or some images. You need some domain knowledge to label the information. And you need a credit card. But you can go away and do this for yourself and in the background start to train models and do some interesting things. But there's a word of caution. How many of you in this room would submit a paper to a top medical journal, the results of an RCT or a meta-analysis, without getting your favourite statistician to have a look at it first? You do also need people who understand the data science, the statistics, and the mathematics behind it too. So actually, my word of caution here is, yes, you can do this for yourself, but you do need some domain knowledge too. You need to understand the assumptions. You need to understand the limitations of the systems you're working with. You also need to understand the implications of bias in your data set. And there are some really good examples around the world of where things have gone wrong with biased data sets. There's a very large tech company who built a machine learning system to screen CVs to employ research engineers. And what happened when they launched it after years of data going into it? It selected white Western men. And of course, what they had failed to think about in that case was actually the data set they were training with was about 90-something odd % white young men. So there are all sorts of implications to these technologies that we have to be mindful of. So we can do these great things already. So what is the challenge? Well, there's a lot of evidence out there, actually, that even with where we are now, the state of the art in analytics and machine learning, there's probably around about 10 years' worth of work in healthcare just to use the technologies that are out there and to put them to good use. And I think about a lot of the technologies I've just shown as similar to a database, which actually is a bit of a perverse analogy, you might think. Some of you might remember 1970 when IBM first coined the term relational database, or SQL or SQL database. That was a revolution at the time for what's now coined data science, I guess, because it allowed you to structure data. It allowed you to index data, and it allowed you to query data, and query data at scale, and start to ask increasingly more interesting and more complex questions. And actually, in my mind, a lot of what we can do with data science right now, some of the classification and the imaging you just saw, is partly very similar to relational databases, because it's allowing you to automatically start to find and restructure your data and begin to then layer on more interesting and more complex questions. So what we do is take this minefield of data that we see in healthcare, a combination of structured and unstructured data in freehand in the clinical notes, and begin to add more structure to it. And it's with that increasing level of structure we can start to solve problems. So that brings me on really to CMR's approach. I think of CMR as a hybrid, an engineer, a scientist, and a clinician. Because actually what we're really passionate about is solving problems. So that's identifying problems in surgery, in surgical pathways, in surgical techniques, in surgical training, places where errors may occur and go unnoticed. And we also then focus on finding a problem, but not just any old problem. What we really care about is a problem that, first of all, works in practice. It integrates into your pathway. It integrates into your practice. It works with you rather than against you. And, importantly, systems and solutions that we can make a difference. So, artificial intelligence was in the title of my talk. What does that mean? There are many definitions out there. Partly my take on this, and even though this isn't my job title, it's marketing hype. Why do I say that? Because actually we're a long way off any form of general intelligence. And part of my answer here is actually the picture on this slide, the very complex cityscape in the background, that difficult surgery with some challenges ahead for you. Lots of things can happen throughout it, the unpredicted, the time where a box falls off the back of a passing wagon, and there's a choice between hitting that or a child on a bicycle. So you have a driver at the wheel who can intervene, who can think laterally, who can take an action, and importantly understand the action, at least post hoc, which is the ability to come along and explain why they did what they did afterwards. But also, in smart cars, the technology next to you, the autonomous augmented assistive intelligence, the things that are watching your back. How many of us drive these days without ABS brakes, without power steering, without blind spot information systems, without cruise control? All of those things are there to watch your back, to work in synergy with you. And actually, that's our approach at CMR, to work with and not against. We spent a lot of time working on our technologies, and one of the things that's really important to us is actually getting it right. We care about trust, being responsible with people's data, doing things that are ethical, working with you in a synergistic way, explaining why our systems have made a decision in the same way that actually it should be obvious why your ABS brakes kicked in. But most importantly, actually collaborating. There's no point us sitting in our offices in Cambridge, coming up with solutions and making decisions about our technologies in isolation, because frankly, that doesn't work. How many times in my career have I seen dashboards looking at theatre efficiency? I've almost seen as many different dashboards as I've seen sometimes as theatre cases I've conducted, which is quite a lot. So actually, what we care about is collaborating with our customers, collaborating with academics, working with you where we can provide the data science, the technology, and you can provide your problems, and we can work with you to find solutions. So what does the future look like for surgery through CMR's goggles? Well, I'm afraid I'm not giving any secrets away right now. But there's a lot coming your way soon. But please just take away from today, we care about trust. We care about working with customers and others to find real solutions that we can prove work and make a difference in healthcare practice. Thank you very much for your time.